welcome to my channel. Today let's look at the pigeonhole principle, and then we shall look at its generalization. We shall look at the generalized pigeonhole principle and then see how to apply. Now, so what does the pigeonhole principle state? Well, suppose that it says that suppose that we have n pigeonholes. Suppose we have n pigeonholes, and we also have n plus 1 or more pigeons. So I want to see how will these n pigeonholes occupy the n plus 1 or more pigeons. Now, so when you look at that, if you try to distribute the n plus 1 or more pigeons in the n pigeonholes, then you discover that that at least one pigeonhole has more than one pigeons. Because the number of pigeons are more than the holes, the pigeonholes. So if they were to all of them go into the n pigeonholes, then at least one pigeonhole would contain more than one pigeons. So that is what the pigeonhole principle states. The example is this. Take 14 students, and the question is, okay, these are 14 students, and we also take this to be the pigeons, and 12 months of the year, take this to be the pigeonholes. Then you will see that at least we have at least more than one student who are born in the same months. More than one, there must be at least more than one student. At least more than one student, the pigeons here. At least more than one student were born in the same month. So we could have maybe 2 students who are born the same month, or 3 students who are born the same month, and so on. Because the number of pigeons are more than the number of months. Now, so we can generalize this, and have the generalized pigeonhole principle. The generalized pigeonhole principle. And so what does this state? Let me just erase this part. Just erase this part and see. So here we have the same in the generalized pigeonhole principle. We have just clear everything. Let's assume that we have n pigeonholes, and in these n pigeonholes, we want them to be occupied by n m plus 1. This is n times m plus 1 pigeons or more pigeons. But let me say that I want the n pigeonholes to be occupied by mn plus 1 or more pigeons. And let's think, how will they be occupied here? They are more than the pigeonholes. The pigeons are more than the pigeonholes. So that means that there is at least one pigeonhole with m plus 1 or more pigeons. At least one of the pigeonholes has m plus 1 or more pigeons. So this is the generalized pigeonhole principle. That's what it states. And the example is this. Example is this. Find the number of lecturers. Find the number of lecturers in a department so that 5 of them were born in the same month. Were born in the same month. So find the number of lecturers in the department so that 5 of them were born the same month. So for me to find the number of lecturers that must be in that department so that 5 of them were born in the same month, what I need to know is that in a year we have 12 months. In a year we have 12 months. So these 12 months are our pigeonholes. These are our pigeonholes. And this is n. This is n in our statement here. This is our n. And then using this generalized pigeonhole principle, we know that at least one of these pigeonholes has m plus 1 pigeons. At least one of these has n plus 1 pigeons. So this n plus 1 is 5. The one that 5 of them were born in the same month. 5 of them were born in the same month. So that means m plus 1 is 5. So what this means therefore is that m is 4. So to get the number of pigeons, that is the number of professors, then the number of these lecturers. The number of lecturers therefore will be given by mn plus 1, but m is 5. M is 4, and n is 12. Then add 1 and get that 49 lecturers. So this department should be having 49 lecturers so that 5 of them are born in the same month. So that is how we generalize the pigeonhole principle, and you can see how we've used it. So the good thing here is that try to understand the statement of the pigeonhole principle and then the statement of the generalized pigeonhole principle, and try to read more on how to apply and look at more examples.